Welcome to another coding tutorial, and in today's video I'm going to show you how to make this cool graphics that I think would be a good tool for meditation. Why did I just say that? As you can see here, it looks like a breathing in and breathing out, as the circles are going in and out, up and down, just like that. So let's get started. First, we want to, how about just create one block? So I'm going to declare a few variables. The first one is, how about we call it block calls for block columns, and let's set that to 5. And we're gonna do block rows and set that also to 5. And then for the size, let's call it block size. Let's set that to 100, and this is going to be the size of the width and the height of the whole block. All right, so now inside the draw function, let's start by just drawing a set of 25 circles, right? 5 by 5. So I'm going to use a nested for loop. So for let I equals to 0, I less than block columns, I plus plus, and then for let j equals to 0, j less than block rows, j plus plus. Then we're going to use an ellipse function, right? So the ellipse function takes in a total of 4 arguments. The first 2 are the x and y coordinate of the center of the circle, and then the third and the fourth are the width and the height. We're going to put I times, we need to declare one more thing, which is the circle size, right? And the circle size is going to be calculated based on the block size divided by block columns. As you can see here, the number of columns and the number of rows, we have it to be the same. So I can just do block size divided by block columns. Perfect. So now we're going to do I times circle size and then j times circle size. By using this equation, we can evenly space out the circles. And then we want the size to be circle size and circle size. Okay, let's run. All right, so now we have a set of 5 by 5 circles. As you can see here, right, it's missing half a circle to the left and half a circle up. So we want to also add an offset of circle size divided by 2 plus here. Same thing for the y coordinates, so circle size divided by 2 plus. Perfect. Now I want to center this block right in the middle of my canvas. So right now, if we were to change the value of the columns and the rows for the blocks, it's within this range of the block size, right? Let's say that if we change this to 200, that's how we're going to change the size of the whole block. But now I want it to be in the middle of my screen. So how would we calculate that? To be able to center this piece of block, what we need to do is that we need to calculate what the margin should be, and then we translate by that amount to the right and then down. To calculate what the margin should be, there's a few dimensions that we have. First, we have the width, right? And then we have the height, and then we have the size of this block. So to get the margin, we have to subtract the width by the block size. And then the margin, we also need to divide it by 2, right? Because we want to evenly spaced between the left side and the right side, and also the top and the bottom part. So we are going to translate it by width block size, right? And then divide this by 2 to get that half of the margin, right? To get the margin, which is half of the 2 margins. Same thing as height minus block size, and then divided by 2. And now our block is at the center of the canvas. Perfect. So now before we continue, I'm going to put this block inside a class. So we just come to this arrow here, click the plus sign, click create file, and then let's name it block.js. Before we start writing a class, let's go to index.html file, and then come to this line of code, copy, paste, and then change the name to whatever the file name that you just created. In my case, block.js, and this is how you integrate a new file into the program. Let's go back to block.js. Now we're going to start writing a class. I'm going to call it block, then we're going to have a constructor method function. and display. Perfect. So now let's go back to Sketch, and we can first, let's copy and paste these variables here inside the constructor function. All right, and then we want these nested for loop inside of display. Okay, so we also need to change this to let to this dot, right? This dot, this dot, and this dot. And then the circle size will have to be calculated, right? So it's gonna be this dot block size divided by this dot block calls. And actually, I'm going to, let's set a parameter called num. And I want the number of columns and the number of rows to be the same, and I'm going to use this parameter to set the number of block columns and block rows. Okay, so now we also need this dot here and all of this. Okay, so let's start by creating this block object before we start doing anything. I'm gonna create a new variable called b, and b is going to be a new block object, and we need to give an argument of the number of rows and columns, right? So let's do 5. Oh, and we need size. I'm gonna set size to be the same at 100, the smaller block size, and I want to set our block size here to size, which is a global variable. All right, and then I'm gonna call the method display. Let's click run. And oh, and then this we need to translate by size. Block size is not a variable here anymore. Perfect, so we have one block. Now let's create a bunch of blocks. So I'm going to first declare the number of columns, let's set it to 3, and then the number of rows, let's set it to 3 as well. And then instead of this block b variable, right, we're gonna create an array. Let's call it blocks, and then I'm gonna use a nested for loop to create these new objects inside a 2D array, right? So I less than calls, I plus plus, for let j equals to 0, j less than rows, and then j plus plus. All right, and then first we need to populate the blocks array with empty array, right? To create a 2D arrays, and then inside this inner array, this inner loop, we can create the new block objects, and we're gonna set it to 5 by 5 circles as well. Perfect, and then we can copy and paste this nested for loop, and then we can call the display function. Let's click run. Ta-da! We only see one block, but not 9, right? We want 3 by 3, we want 9 blocks. Right now, all the blocks are displayed at the location of 0, 0. And it is 0, 0 because if we were to comment this out, as you can see here, all the starting x and y location is the same. We want to go back to block.js and declare this dot x equals to x, and then this dot y equals to y. Let me comment some stuff. So these are block variables, and then this one is circle variables. Perfect. So we want to declare these two new variables or arguments because we want to translate each of these blocks by that amount, right? So basically we're gonna translate it by this dot x and then this dot y. By using this translate function, basically we're trying to translate the origin point of each of the blocks by the size amount. So it's the same logic of how we evenly space the circles. We multiply which column it is or which row it is by the size of the circle, and in this case the size of the block. So now that we have this translate function, we can go back to sketch.js, and then we need to give it two more arguments here, right? Which is going to be I times the size, right? I times the size, and then j times the size. And then this should do it. But it didn't. You only see 2. And that is because we forgot 2 main functions when we do transformations. So we need to use the 2 functions called push and pop. Anytime we do transformations, we need to think about the starting condition or the starting transformations at which you want to transform by. So in this case, we want to transform from the 0, 0 point, right? That is the origin point that we want to start from. So we need to use the function called push and then the function called pop. And that is because the push function basically saves all of the transformations, in our case, translate, right? We want to translate by this amount so that we can draw the circles here, and then here, and then here, I mean the block. And then once we do all the transformations and then we call the commands, then pop returns it back to the original setting, which is where the origin is at 0, 0, which is this point here, right? And so if we click run, now we see that they do not overlap anymore. But the reason that you see that it's moved from here to here, that is because we have this other translate function. So if I comment this out, then it's at the original point. And as you can see, when I use this translate function, we wanted to call this function so that everything is centered in the middle, right? But the reason that it's not is because the calculation that we did for the margin is not correct anymore. Because the size here, the size of this variable is only the size of one block. So we also need to multiply the size by the number of columns and then the size here by the number of rows. And then if we click run, now we have multiple blocks that are centered on our canvas. But right now, because all the circles are of the same color, we cannot really see which circles belong to which block. So I'm going to also declare another variable called C, and then let's do a random value between 0 and 255. And then I'm going to fill that color by that amount. Okay, so now you can kind of see. What we want to do next is that we want to draw those moving circles, right, that are inside these circles that we have drawn. So let me tweak the code a little bit. So how about we declare a variable called x, and then we're gonna put this inside here for x, and then y, and then we're gonna copy and paste this part for y. And so the new circles that we want to draw that are gonna be inside all of these circles, right? It's going to be at the same x and y location. The difference is going to be the size, right? But I want each of the circles to have different sizes. So what I'm gonna do is that I'm gonna create a 2D array. And this 2D array, how about we call it moving size, right? And then to populate this array, we need also a nested for loop. So let I equals to 0, I less than this dot block of columns, I plus plus, and then for let j equals to 0, j less than this dot block rows, j plus plus. Then in this outer loop of I equals to empty arrays, and then in here of I and j will be equals to, what if let's start at, I'm gonna set it to, how about 5. Okay, and then this would be this dot moving size of I and j, right? Oh, I need a j here. All right, okay. And then I want to fill the inner circles to be white. Oh, so it's like this. So basically I just need this fill to be in here. Perfect. And how about we do no stroke for everything? Alrighty. But then now the moving size array have the same size for all of the circles, right? So I want to change it, and I want to differentiate it by I plus j. Okay, let me actually go back to sketch.js, and then let's make this column 1, rows 1, and then let's say the size is 300. So we have one big one first. All right, so basically I and j gives it this diagonal pattern. When I equals to 0 and j equals to 0, the moving size is 0. And it gets bigger and bigger and bigger as you move down this diagonal line. That is good and all, but now we want to move it so that we get that breathing diagonal pattern that we saw at the beginning of the video. And we can do that by writing a new method. Let's call it move. And then we're basically going to move the moving size of, let's do an argument of x and y, of x and y index here by a specific amount. Let's do this dot speed, and then let's declare this dot speed to be, how about, let's do 1. And then we also need to call it here, right? So to call a method inside a class, we just say this dot and then the name of the method, move. And then we need to put I and j in here. Let's try that. Whoa. What happened there? So we need to set a condition, right? Because the size of the circles gets so big and it just keeps getting larger and larger. So what we want is that we want to say if this dot moving size of x and y is greater than this dot circle size, or if this is less than 0, what we want to do is that we want to change the direction of the speed, right? So from 1 to -1. So we can just multiply by -1. So let's try that. Okay, that's better. It's a little bit subtle, so I don't know if you can see it, but basically when this circle here hits the limit, right, it changes the speed, because right now the speed is the same for all. Okay, now it's more clear that you can see that like this hasn't even hit the limit, but it has to change its speed already. So what I want to do is that I want to give each of the circle a different speed, basically. So I need to create a new array called speed. So we can delete this, and then this dot speed will be initialized at, let's do 1, and then this dot speed of I will be equals to an empty array. So we do the same syntax, right, for these 2D arrays. Okay, and then here we also need to say speed of x and y. Now if we do that, whoa, oh, here. All right, so you can see that each of the circles need to hit the limit here before it changes. I think you will be able to see it more clearly if I reduce the speed down. Quite slow. Okay, so this one hits, and then these hits, and then these hits, and then these hit, and then these ones. Perfect. Okay, so now that we have the moving mechanics working, let's go back to sketch.js, and then we're gonna change it back to 3x3 and then the size of 100. Okay, we're almost there. From the original graphics, the number of circles in each blocks are actually different, but they're not that much different. So every odd ones have the same number of circles, and then every even ones have the same number of circles. I need to write a conditional statement. And what I'm going to do is that I'm going to write if I plus j mod 2 equals to 0, And then you might be like, Pat, what is going on here? Okay, let me quickly explain. Else, and then let me copy this. So what is happening here is that you can see, actually, how about we stop the moving function first? Oh, all right, so we have a total of 3 by 3. So this block here is when I plus j equals to 0. These two blocks here are when I plus j equals to 1, and then 2, 3, and then 4, right? So this is even. All of these ones with 5 by 5 circles are even. This expression here is called mod, and basically what it does is that it tells you how many of the remainder is left from this division. When this number is divided by the number 2, what are the remainders? So if you divide something by 2 and you get the remainder of 0, that means it's an even number, and vice versa. If it is not equal to 0, then it is an odd number. So I'm just basically using this expression here to figure out which of these blocks are even and then which are odd. And this should work for other number of columns too. So let's try 4 by 4. And if we were to give it smaller, then let's do 6 by 6. Yeah, right? So because when you do I plus j, it gives you that diagonal pattern. But you can see there's some stuff that is not working very well right now. You can see that these are super white. Why is that? And these white colors are what? These white colors are the color of the inner circles, right? And because these ones that are super white actually have the number of 10 by 10 circles. And the reason that you see all of these white stuff is because, let me actually put it back to 100 and 3 by 3 first. It's because if you go back to block.js, the initial moving size that I gave, is I plus j. And because with 10 by 10, the diameter there is very big. So we would want to also multiply it by a constant. So let's do 0.5. How about that? Okay, that works for this configuration. And then let's uncomment the moving function. That looks pretty good. How about we change some colors? Let's start by, I want to set the outer color to white, but I want the transparency to be 100. Okay, and then I actually want the inner one to be orange. Okay, and then let's set the background to be this navy blue. And there you go. Breathe in, breathe out. Don't you think it's a good meditative tool? I really think so. I think this piece is really fun to make and also provide you with a concept of how to create this one tile, put that into a class, and then create a bunch of tiles in rows and columns from that and create a pretty cool animation out of it. Give this one a try.